Alright, so this presentation is going to be about the Nazca plate. Just some quick vocab before we get into the presentation. A divergent boundary is where two plates move apart from each other. A convergent boundary is where two plates are moving towards each other. And a subduction boundary is a type of convergent boundary where one plate will slide underneath the other plate. Alright, the crust type of the Nazca plate is oceanic. As you can see, it is all water. And I believe that is actually on the South American plate, this little bit there. Alright, neighboring plates of the Nazca plate. So this is the Cocos plate to the north. This is the Pacific plate to the west. Antarctic to the south. South American to the east. And then there is a little plate in here called the Panama plate. Alright, so types of boundaries. Between the South American and the Nazca plate, there is a convergent boundary, which is where they go towards each other. And the Panama plate, which should be right around in there, is also a convergent boundary. There's divergent boundaries between the Pacific, Antarctic, and Cocos plate. And this convergent boundary right here is actually a subduction where the Nazca plate goes underneath the South American plate. Alright, the speed that the plates are going in millimeters per year. So I also put the direction they're moving. So the Nazca plate is moving east and the South American plate is moving north and slightly west. So as you can see, if the Nazca plate is moving eastward, so that would be this way, and then this South American is moving westward, they're moving towards each other, convergent. Alrighty, and then another example. We'll do the Pacific. So Nazca plate's moving east, Pacific is moving west, which means apart from each other. One more. We'll do Cocos. And yeah, we'll do Cocos. So Nazca plate is moving east, Cocos is northeast. So Nazca, Cocos is going northeast. Alright, some evidence that the plates or some evidence about the plates, how we know what boundaries are at each plate. So just for starters, this is an example of a subduction boundary. As you can see, this would be the Nazca plate right here because it's the oceanic crust, and it is subducting underneath of this one, which would be the South America. So like the Nazca is right here, the South American plate would be kind of like right there. So the Nazca is going underneath the South American plate, which then pushes up sediments and other things to make a not volcanic area, like mountainous hilly area. Alright, so starting here, well not starting, but continuing on to the Chile Rise. So the Chile Rise is where the seafloor is spreading and it permits magma to rise, and it's at the southern edge of the Nazca plate and is where it is spreading away from the Antarctic plate. So that would be like right here is where the Nazca ends, and then this would be Atlantic, and they're moving apart from each other. So then magma comes up and next. So the Andean orogeny, that would be between the Nazca and the South American plate here, and they're going together, which makes the Andean orogeny also the Andes Mountains. This is an elevation map to show that the Andes Mountains is higher up, where the plates are meeting there in the middle. Alright, this is the age of lithosphere map, so I have it blown up a little bit so you can see it better. So this red is where, obviously in a million years, the red is the youngest. So along the Nazca plate here, you can see that it's the youngest. So that shows that the plates are diverging against each other. There's a divergent boundary, I should say. And the new magma is coming up through the plate, which makes that magma is younger than, like, let's say the the stuff over here is older than what is coming up. So you can see there's a divergent boundary along the western side of the Nazca Plate. This could also show that it is hotter because the magma coming up would be hotter than the stuff that's over here that's had a long time to cool. And that is it.